Hey everyone, welcome back to my channel. My name is Ron and I'm going to share the fundamental skills you need to truly grow as a developer. Trust me, mastering this will help you a lot, no matter your experience level, so let's dive in. And the first point is object-oriented programming. You won't believe how many experienced developers don't really understand polymorphism, inheritance, or even how properly use interface. Why? Because they only studied the theory, maybe wrote a small snippet here and there, but never actually implemented it in a real project. So, if that sounds like you, it's time to change. Implement, test, and see how it works in real world scenarios. And the second is data types. You'll need to know how to handle primitive data types, understand the life cycle, and know what goes into the heap versus the stack. If you don't get this right, you'll struggle to write efficiently high performance code. So, take time to study and really understand how each data type works. And the third point is data structure. You need to master the most commonly used structures: arrays, linked lists, stacks, queues, trees, graphs. Oh, but I never used a graph in my life. Okay, maybe not every day, but imagine someone brings you a problem and you realize a graph is the best solution. You don't need to use it all the time, but you should at least understand how it works and be prepared to use this. 4. Collections. This includes essentials interface like iterator, set, list, map. Notice something? Two are directly related to data, and that's because as developers, our job is all about handling data. We fetch data, transform data, store data, delete data. We're constantly working with data. So, mastering this concept will make you much stronger developer. And the point 5 is algorithmic complexity. Imagine you have a list with all your friends' names and you need to find one specific name, and you need to find, and if this list is small, no problem. You can just scan through it quickly, but what if there are a million names? That's where things get tricky. Algorithmic complexity helps measure how fast an algorithm can solve a problem as the input size grows. To describe this, we use something called big O notation. It tells us how the execution time of an algorithm increases as we add more data. For example, if someone says this algorithm has linear complexity, it means that the execution time grows proportionally to the number of elements. If it's a logarithmic complexity, the time increases much more slowly as the data grows. Alright, that's my list. But what about you? Do you have anything else you consider essential? Drop a comment below. I'd love to hear your tips. If you enjoyed this video, hit the like button, subscribe to the channel, and turn on notifications so you don't miss the next video. Thanks for watching, and I see you in the next one.